Alright, so the first thing I'm going to do is change this IP coding to Notes Video R. Alright, so we have f, g, and h, and they're twice differentiable functions of x with the values as given in the table. This word might throw you off, both those words. Okay, all that means is that both or all three of these functions, f, g, and h, can be derived twice, 2 times each. So I can find the derivative of f, and then once I find f prime, I can find the next derivative, which we would indicate as f double prime. I can find g of x's derivative, it's differentiable, and then once I get g prime, I can find g double prime, the next derivative, and then the same thing for h. Okay, and so that just implies that you can find 2 derivatives, and also don't forget that if a function is differentiable, it's also continuous. All right, so we're going to use this data to help us. So down here, the questions are find f prime of 4 for each of the following. So when we see f prime, that tells us that we're going to have to differentiate f. We'll notice that f is given to us, but it's given to us with generic notation. So in order to find f prime, we just have to identify the structure of the function and then apply the appropriate differentiation rule. All right, to save space, why don't we not work underneath the problem, but move the work over here underneath the blank. All right, so I've identified that this is a composite function where h of x is on the inside and x cubed is the outside function. So if we have a composite function, we're going to have to use the chain rule. So f prime of x equals, well, the outside is x cubed, so let's bring the 3 in front and keep h of x. Parentheses or brackets are acceptable. We're going to drop the exponent to 2, so it's the power rule on x cubed. But we also have to multiply this by the derivative of the inside function. And the derivative of h of x is h prime of x. So we can avoid the d over dx notation since it's kind of a basic derivative. Okay, so next thing is, since we've done our differentiation, is we're going to evaluate this function at 4 as requested. So the next thing we're going to do is everywhere we see x in the derivative, we'll replace it with 4. Alright, so we're going to go up to the table and retrieve h of 4. So once we find that our input, our x value is 4, we're going to move over until we find the h of x value. H of 4 is 6. And then we're going to multiply that by h prime of 4. That almost looks like a 9. So then we're going to go again to our input of 4, and we're going to move over until we get to the h prime value at 4, which is negative 5. So that's times negative 5. Okay, so f prime of 4, again that looks like a 9. Make it a little bigger. Alright, that's 36 times 3, which is 108. 108 times negative 5, once we do the computations, 108 times negative 5 would be negative 540. Alright, coming over here to B, we're going to find f prime of 4. Well, noticing what we have as far as a generic equation here, to find f prime of 4, I'm going to use the sum and difference rule for differentiation. So the derivative of g of x is g prime of x. And let me come back here, and I'm not at f prime of 4 yet. I need to first of all find f prime of x. Then I'll plug in 4. I think I'm putting the cart before the horse. Alright, plus the derivative of h of x is h prime of x. Differentiation is complete. Now we'll go ahead and plug in 4 wherever we see x. Alright, go up to the table, retrieve g prime of 4. So 4 is my input, g prime is 2. h prime of 4 can be found from the table when the input is 4, h prime is negative 5. Okay, so f prime of 4 is negative 3. Right, if you feel like you know what you need to do with these problems, because that's what we're doing, is using generic functions. If you think you know what you do, this might be a good time to maybe stop the video and complete these on your own, and then come back and check to see how you did. Self-assessing is a good thing here. Instead of just watching, attempt them on your own and then make any changes when you come back and watch the video. All right, so for problem C, let's find f prime of x first. Well, when I study what f of x is equal to, I notice that we have a product here. We have g in terms of x and h in terms of x. So we're going to have to actually apply the product rule here to this generic notation. So the first factor times the derivative of the next factor plus the second factor left alone times the derivative of the first factor. We're going to plug in 4 everywhere we see x and then retrieve those values from the table. All right, I've scrolled past the table, but I know you have it in front of you, so I'm looking at mine too. G of 4 is negative 3. So I think what I'm going to do is kind of build the framework here. I know I need to find 4 values from the table and perform these computations. So G of 4 is negative 3. H prime was negative 5. H of 4 is 6. And G prime of 4 was 2. So 15 plus 12. I'm running out of room here. Otherwise, if you have room, go ahead and put down f prime of 4 equals 27. But what I'm going to do is just put the answer up here in the blank. All right, going to example D here, we see that we have a quotient, so that's going to require that we use the quotient rule for differentiation. So the quotient rule always begins, at least I begin it, by taking the denominator of the problem and squaring it, because that becomes the denominator of the answer. And then it just tells me that I need to start the numerator with h of x left alone. The quotient rule is the one where students kind of get these mixed up and switched. So if I do this, it helps remind me, okay, how to set this up. So, and then I need to multiply that by the derivative of the numerator. The quotient rule is minus, whereas the product rule is always plus. Minus the numerator left alone times the derivative of the denominator. And everywhere I see x, I'm going to replace it with 4. And being almost out of room here, I'm going to move to the side here. All right, h of 4's value is 6. I need to square it. And on the top, I'm going to build the framework, I guess, here. So h of 4 again is 6. G prime of 4 is 2. G of 4 is negative 3. And h prime of 4 is negative 5. So in the numerator it's going to be 12 minus, this product is 15 over 36. So negative 3 over 36, and that's going to reduce to negative 1/12. Right, this is just a way for us to practice our differentiation rules, but also work with generic notation. Again, if you're feeling comfortable, pause the video, attempt it on your own, and come back and check your work. This is the difference rule. So the derivative of each term evaluated at 4. G prime of 4 is 2 minus H prime of 4 is negative 5. Alright, and the result is 7. Alright, example F. Okay, studying the equation and what differentiation rule is necessary. It's a composite function. It's really important to pay attention to the difference between a composite function and one that has a product, I should say, of two functions. Notice that g does not have its own x, so this is not g of x times h of x. This is not the product rule. This is a composition. H is inside of g. Compositions require the chain rule. So we've identified the outside function is g, so we're going to find that derivative first, but we're going to leave h of x alone. But then we have to go back and multiply by the derivative of h of x, which is just h prime of x. Okay, and here's where it can get a little tricky when you're evaluating at a specific input. Okay, so we need to do h of 4 first, and that is 6. So this is still g prime, but now it's going to be evaluated at 6 because all of h of 4 is 6. And then I'm just going to go ahead and bring down h prime of 4. I won't find that value until the next step since I still have yet to find this value from the table. It wouldn't be wrong to put the value of h prime of 4 here, but I'm just going to do it all at the same time. So g prime of 6, okay, now look, we get to go to another x value finally. G prime of 6, dropping down to where x is 6 and going over to g prime of 6, I'm going to get 7. And then I'm going to multiply 7 times h prime of 4, which is negative 5. So that product is negative 35. So again, if you need to go back and process this, this is a trouble area right here for some students. So that's a composite function. Okay, look at G. If you want to attempt G on your own, that's similar to A. That might be a good idea, and then come back and check your work. All right, we need to find the derivative of f of x, or f. We need to get f prime of x. Hold on. All right, we see that this is a composite function. The inside function is g of x, and the outside function is x squared. So again, a composite function requires the chain rule. So the derivative is 2 times g of x, drop the exponent by 1. Okay, you can put it there or not. Leave g of x alone, but don't forget to go back and multiply by the derivative of the inside function, g of x. All right. Now we can evaluate at 4. So this is twice the value of g of 4. G of 4 is negative 3, so twice negative 3, and then that's multiplied by g prime of 4, which is 2. Alright, and then multiplying all this together, negative 6 times 2 is negative 12. Alright, and one more composition. We can see again in H, it's not the product rule because H doesn't have its own x, so it is a composite function. That's a multiplying. Alright, so g of 4 from the table is negative 3, so I'm going to have to go back up to the table and find h prime at negative 3. G prime of 4 I'm just going to bring down. So new row, we're using -3 as our new input value, x, so h prime of -3 looks to be 4, and g prime of 4 now, g prime of 4 is 2. So it looks like that product is 8. F prime of 4 is 8. Okay. So we practice our differentiation rules on generic equations. So let's look at these last two down here. Okay, notice that you're asked to write the equation of a line that's tangent to this function that we don't know what it is. So the first thing is write equation of a line. Immediately point slope. So put yourself on task and on track. Maybe come over here and write the point slope formula. Okay, so in order for us to use this, we're going to need an x-coordinate, a y-coordinate, and slope. I see that the x-coordinate is 4. I need the y-coordinate and the slope. Well, getting the y-coordinate is pretty easy. You just plug it into the given function. That's f of x. Plug it in for every x. And go ahead and use your table to find the y-coordinate. The slope is going to come from the derivative. All right, so I think I'll start there. I think I'll first find the derivative, plug in 4, and use my table to help me get the slope, and then I will find the y-coordinate by using f of x. Alright, so let me go ahead and find the derivative. Alright, so studying what we have here, think of this as one factor, and think of g of x, whatever that function is, as a second factor. So thinking of factors tells us we're going to use the product rule. We have to use the product rule on this function. So the first factor left alone times the derivative of the second factor plus the second factor left alone times the derivative of the first, which is 2x. It'd probably be best to pull the 2x in front of g of x because, you know, we are not multiplying these two together. Okay, I think I'll do that my next step as I plug in 4. So 4 squared, which will be 16, of course. We'll go to the table and find g prime of 4 plus, I'm going to plug 4 in for this x here and get 8, and I'm going to put that in front of the g of x factor. So that's g of 4 now. Alright, so we've got 16. Alright, g prime of 4, you'd think I'd have that memorized by now. G prime of 4 is 2 plus 8 times g of 4, which is -3. Okay, so this is going to be 32 minus 24. Looks to be 8. 32 minus 24 is 8. Yep. So the slope, because remember that's what this notation means, the slope, or the m value that we're going to put in here, is 8. Okay, the next thing we're going to need is the y-coordinate. Remember, we need a point, and all we have is the x-coordinate, so we need the y-coordinate now. Well, the y-coordinate is going to come from us plugging in 4 to the function. So I'm going to get it right here in front of me again. So just plug in 4. So that will be 16 times g of 4. So 16 times, I don't know why I don't have this memorized, -3. G of 4 is -3. So my y value is going to be -48. Alright, so just pay attention to your notation. Know that the prime means slope, and without the prime, you're just using the regular function, you get the y-coordinate. So coming over here, I'm going to have y plus 48 equals 8 times quantity x minus 4. Alright, similarly, looking at number 3 here, we're going to write an equation of a line immediately. We know that's point slope. And all they gave me was an x-coordinate, but they gave me the function that I can use to find the y-coordinate, and because I have the function I can differentiate and get the derivative to get the slope. So similar to this last problem, you might want to attempt it on your own. Just make sure you know that the derivative of this term is going to require the chain rule. Alright, so I'm going to find the derivative first so I can get the slope. So the derivative of this first term is the derivative of the outside. Leave g of x alone. times the derivative of the inside function. Now, plus, look at the derivative of 6x. That derivative is just 6, because the slope of that linear function would be 6. F prime of 4, oh, pardon me, f prime of 6. It changed. I'm going to evaluate this at 6. And I'm just going to bring down the plus 6. It's important, it's part of the problem, it's part of the slope. Alright, going up to the table, g of 6 is 4, so I'm going to keep the h prime, and that's my new input on my h prime. I'll just keep this as g prime of 6. Remember, we're multiplying, and then plus another 6. Alright, h prime of 4 is negative 5, so this is negative 5. G prime of 6 from the table is 7, and then we're going to add 6. So negative 35 plus 6 is negative 29. Okay, think about what we found. We just found the slope value. We have the x coordinate. We still need the y, and the y always comes from the function. So f of, let me get the equation down here. Okay, and all I'm going to do is plug in 6 everywhere I see x to get the y coordinate. G of 6 is 4, so this will be replaced with 4. I still need to find h of 4. I'll go ahead and multiply here. Let's see, h of 4 is 6. So this becomes 6, and I'm going to add 36. So this is 42. So this is your x sub 1, this is your y sub 1, and this is your slope value. And we've completed the request of writing the equation of the tangent line. So hopefully this video helped review some of the differentiation rules and when each of them are necessary to be used, and also it helped kind of familiarize you with using generic notation as well.